Okay, thanks everyone for joining this session. So now I would like to discuss about EIGRP. So let's discuss about EIGRP routing protocol. Okay, so EIGRP. What is EIGRP? It's a dynamic routing protocol. What is it's a dynamic routing protocol. Okay, na? So simple. It's a just dynamic. It's a dynamic routing protocol, same as OSPF. You know, right? How dynamic routing protocols will works. Once you advertise, networks, it will discover the neighbors, then exchange the routes, and calculate the best path and put the best path in routing table. That's the process. And consider, these are two or Cisco devices. Okay, and same like it's very similar to you know it's very similar to OSPF. So now tell me how to configure EIGRP. So first you need to go into configure terminal and router. It's a EIGRP protocol, right? Type EIGRP and what we need to give next. Can anyone please tell me?
100.
Yeah, autonomous
The
system number. Yeah,
autonomous system number.
anything you can give. Okay, I'll take 90 or something, anything. So I'm just taking 90 because to remember the things like what is the AD value of EIGRP? What is the AD value of EIGRP?
R1.
No, advertise distance. AD means advertised distance of EIGRP. It's 90. What is the OSP of advertised distance? Administrative
110.
distance 110. So here
110.
EIGRP administrative distance is 90. Okay. So just to remember the things, I just taking a 90 as the autonomous system number. Then one you enter into the EIGRP. So what you need to do? Same. You need to advertise the networks. Now tell me. So this is 192.168.1.0/24 network. So what you can give here, you need to advertise, right? What is that? Network 192.168.1.0 and wildcard mask
0.0.0.
0.0.0.255.
0.255.
That's it. And in EIGRP, we don't have any areas. We have a limitation here. So you can configure EIGRP routing protocol up to 255 routers, up to 255 hops. There is a limitation. Okay, so there is a limitation for EIGRP routing protocol. Okay, for OSPF we don't have any limitation. However, we create areas. But EIGRP is a enhanced interior gateway routing protocol which was developed by Cisco. So till 2013, it was Cisco proprietary protocol. So no vendor can use this protocol. Only in Cisco devices it was using. It's a Cisco feature. But 2013, after 2013, it became open standard, and Cisco given license to all the vendors. If you want to create my protocol, Cisco protocol, you guys can develop it and integrate in your operating system. But other vendors, why should I integrate your routing protocol? We have a great routing protocol OSPF and ISIS. So why we want to use this your protocol? Because there's a limitation for your routing protocol. We don't want to use that. So other vendors like Nokia and Juniper, they didn't develop EIGRP protocol. Only Arista vendor developed EIGRP protocol because Arista and Cisco have their own, bond. They have their bond, so that's why they did it that. Okay, so that's why I'm not concentrating more about EIGRP. 90% of the networking operations in networking architectures they use OSPF. Very few places they will, use EIGRP, and in interview they might ask you about EIGRP. That's why I'm telling you here. Okay, na? So same like this. So just configure this, and EIGRP will come up. That's it. So it is a distinct vector routing protocol. It means it will count the hops. It will work only up to 255 hops. Okay. The best document is to learn EIGRP is 9tube.com. Just opened it, and I will give you this link to you guys. Open, you can just go through the tutorial. Okay, it's simple, it's very simple. Okay, like OSPF, right? In OSPF, during adjacency process we have a stages, right? Here also we have a stages. So here also in hello packets, right? We how many packets we have in OSPF? we have 5 packets: hello packet, dbd packet, link state request, update, acknowledgement. Similarly, in EIGRP also we have packets. Please remember this. Some kind of interviews they will ask you. Here also we have a hello packet. Same thing. So both the routers will exchange the hello packets through multicast address 229.0.0.9 and 10. You can see, right? It's 10 actually. So 224.0.0.10. In OSPF it is 224.0.0.5. Here it is 10. Okay. So the EIGRP routers, they will exchange the hello packets through 224.0.0.10. Once they discover the neighbors, okay. Someone is trying to join. So then they will start exchanging the routes. Okay. Yeah. So once the neighbors are discovered, they will start exchanging the routing information. So simple. So how many packets we have in EIGRP? These are the packets. Hello packet. Once the neighbors are discovered, they will exchange the routing information in update packet. This is update packet. And this is acknowledge. Like once you receive an update, it will give acknowledge, right? Yeah, here. So hello, update, acknowledge, and query. So query and reply. So query, if it is asking a query, right, it will get a reply. So query means it will find a alternate paths to reach the destination. Okay, in case if the primary path is failed, right? It will ask a query to find a alternate paths. Okay, yeah. So it will get a reply. Okay, this is the best path to reach the destination. So I will tell you. Please remember these packets. How many packets we have? Hello, update, acknowledgement. That's it. And query and reply. So these are the packets. Okay. Please remember. And EIGRP uses diffusion update algorithm, whereas in OSPF it uses Dijkstra algorithm. Okay. It uses Dijkstra algorithm and it's a completely same. Okay, it's a completely same. See here, the process is simple, same like OSPF, like right, router OSPF autonomous system number. Here also router EIGRP and the autonomous system number. It's a process ID. Okay, autonomous system number, and advertise the network. Okay, advertise the network and you will see. Okay, now this is very important. Okay, this is very important which I want to discuss with you guys. Okay, so let's discuss. This is OSPF, right? Okay, let's take a new slide here. Yeah, let me copy this. Okay, are you able to see, right, my screen clearly? Okay, now I would like to discuss about this. Okay, so EIGRP, ad, administrative distance equal to how much? It is 90. And protocol number, can anyone tell me what is the EIGRP protocol number? Protocol number you will see in IP header, right? What is the OSPF routing protocol number? What is the OSPF protocol number?
89.
Very good, ma. This is 88. OSPF routing protocol number is 89 and this is 88. Okay, that's how the internally the router will recognize it's a EIGRP routing protocol. Now see, the configuration is very easy. Now you will see, right? So to reach A to D, so we have how many routers here? Just concentrate. How many routers are here? A, B, C, D, right?
4.
Right, just consider A, B, C, D, there are routers. So to reach from A to D, A is the source, D is the destination. How many paths you have? Can anyone please tell me? A, B, D.
3.
This is one path. Okay, you said 3, right? This is one path. A, B, D. Yes, it's 4 actually. Let's find it out. A,
Yeah,
B,
4.
C, A, B, D is one path, and then
Yes, four,
A,
four.
A, B,
CD.
C, D is one path. Okay, A, B, C, D is one path, and the second path is another path. A, C, A, C, D.
ACDD.
Yeah, A, C, D is another path, and one more path, guys.
ACBD.
Very good.
ACBD.
A, C, B, D. So A, C, B, D. A, C, B, D. Is it clear? We have how many paths in this topology? 4. Okay. So in case of this kind of topology, right, to reach from A to D, you have multiple paths. Generally, in router A perspective, you have two paths, but in transit, there are multiple routers, right? So whatever you see, right, is 40, 50. This is called cost. This is called cost. Just consider it is a cost. Okay, distance bit, link cost. Okay, now there are few things here. Okay, there are few things. Let me pull all the very important in interview. They will ask you these four things. Okay, let me pull this here for you. Hmm. Right. Okay. And what is this? Okay. Okay. Hmm. Okay. Fine, guys. So first one is in interview they will ask you what is feasible distance and advertised distance in EIGRP. Just remember, just concentrate here. So advertised distance means the cost from neighbor to the destination. So in this topology, as per the topology, A is the source, D is the destination. So who are the A neighbors? Can you please tell me who are the A neighbors, EIGRP neighbors?
B and C, sir. B and
Very
C.
good, ma. B and C. So the
B and C.
B and C, right? Very good. So the advertised distance. Go on mute now. Yeah, thank you. So now the advertised distance is it's very simple. The cost from the neighbor to destination. Okay. The advertised distance is now the cost from the neighbor to destination. It means 1 second. Yeah. So it means this is the one. These are the neighbors, right? Yeah. So what is advertised distance? It is the cost from the neighbor to the destination. D is the destination and B is the neighbor. So maybe in between there are multiple routers. Okay. Whatever it is. What is advertised distance? The cost from the neighbor to the destination is called advertised distance. Don't confuse with AD in EIGRP. AD means advertised distance. We have administrative distance also, but administrative distance is 90. But AD you need to calculate as per the topology. The cost from the uh, neighbor to the destination is called what? The cost from the neighbor to the destination is called,
advertised distance.
yeah. Now you tell me. Yeah. Now you tell me. What now? This is a path, right? What is the AD here for this path? AD we have how many ADs we have? One is 50
70.
and second is 70, right? One is 50, another one is 70. Okay, right, very good. Now, what is feasible distance? Feasible distance is very simple. The sum of AD plus the cost between your local to the local router to the next hop router. It means this is your local router and this is your next hop router, right? The cost from your local router to the next hop router plus the AD value. It means total distance. It means total cost. Now tell me what is the cost? What is the okay? I'll do one thing. AD path 1 AD. I can do one thing. Path 1 AD equal to how much? 1 is 50. Path 2 AD equal to how much? 70. Now, similarly, path 1 FD feasible distance equal to total, right? 40 plus 50. How much?
90.
90. Similarly, 60 plus 70. How much?
130.
130. 130. Okay. So how many paths you have? Two paths generally here. Okay. This is it. And you have multiple paths also, right? Four paths. Path 3. Path 3, please tell me what is FD? Same, right? 60 ACBD, right? ACBD.
90.
So 60 plus 30, 90, 90 plus 50. How much?
140.
140.
140. Okay, now path 4 FD.
140.
Same, right? A, B, C, D. It means 40 plus. 30, 70, 70 plus 70, how much? 140.
40.
Is it clear, everyone? How many paths you have? 4, right? How many ADs we have? This is a ADs and this is a FDs total. Okay. Now the thing is, AD means the cost from the neighbor to the destination, and FD means the sum of AD plus the cost between local router to the neighbor router, next stop router. That's it. Now you have 4 paths. Now you tell me the lowest cost will be preferred. So which one is the lowest path here? FD. Which one having the best path here? This one, right? Yeah.
First path.
This is called successor. This is called successor. It means the best path is called successor. Successor means the primary route to reach the destination. The successor route is kept in the routing table. It means this is a path. So this is called successor. Now feasible successor in the sense second best one. So what is the second best one here?
Path 3 and path 4. Second path.
Path,
Second path.
second path, second path. This is called feasible successor. That's it, guys. So this is okay, and okay. Someone is trying to join. Okay, perfect. So understood, right? So this is successor, and so this is primary path, and this is successor, and this is feasible successor. That's it. So this is all about EIGRP. Okay, it's very simple. Have you feel anything hard here? Hello?
No, sir.
It's
No, sir.
very
No, sir.
simple because you know very well about OSPF. That's why it is very simple for you. If you don't know OSPF, it will be difficult. Yes or no? You know OSPF, so that's why the configuration is also very easy. Let's configure the EIGRP protocol. Okay, let's do this. Okay, now configure terminal and let me maximize the screen a little bit. I don't know why it is showing very small size. It's there. Okay. So now, so the configuration is simple. Router EIGRP, how much? 90, and network 192.168.1.0 and wildcard mask. That's it. And give network 1.1.1.1. Loopback also I would like to advertise here. 255, 255. So no. Yeah, this is wildcard mask, right? That's it. Okay. No need to give any areas here. Here also advertise in the same way. Okay. The only thing is you need to remember for interview those feasible successors and advertisement distance only. Okay. Yeah. And the packets. How many packets we have? Can anyone tell me how many EHRP packets we have? Whatever you remember.
5.
5.
Yeah. What are
Hello.
those? Okay.
Hello.
Hello packet update.
Hello.
Acknowledge.
Acknowledgement. Query.
Query reply.
Awesome.
Awesome.
Awesome. Great guys. Within short period you remember very well. Yeah. See, if you learn OSPF, it is very easy to understand EHRP and other routing protocols also like BGP. Okay. So I'm advertising this, and here we don't have any areas. We have only it is diffusion algorithm. It uses diffusion update algorithm, and it will use count. It will count it actually. Okay, only 255. Only 255 hops it will support. Okay. Now show IP EIGRP neighbors. Is it showing or not? No route. Okay.
No, we have
I
not configured interfaces.
Yes, right. That's the reason. Very good. So interface. What are those interface here? Both sides I didn't configure anything. G 1/0 IP address 192.168.1.2. No shutdown. Interface loopback 0 2.2.2.2. That's it. Okay. Now here as well. Interface G 1/0. Guys, I'm typing very fast for configuration. It's not a big deal, right? Hello? Just IP address only. You configure it, right? Already. Hello?
Yes, sir.
Yes, yes.
Yeah. Okay. Now done. Show IP EIGRP neighbors. Same like show IP OSP of neighbors, right? Same like show IP EIGRP neighbors. See now the EIGRP is formed. Okay. If you do packet capture, you will see. Oh, I already configured, right? So see the hello packets are exchanging through what? Which IP? Which multicast address? 224.0.10. And what is the protocol number for EIGRP? It is 88. Are you seeing it here? 88.
Yes, bro.
Okay. Yeah. So this is a EIGRP protocol. Here you will see hello packet and you will see lot of information here, updates, flags. So you no need to dig into more, guys. This is not required. Okay. This is not required. Okay. So it's already EIGRP is already established. See now, if you see show route, right? Show IP route, right? The 2.2.2 is 2.2.2 route will learn here. Okay. Show IP OSP of neighbors. Sorry, EIGRP neighbors. EIGRP. Okay. Show run section EIGRP. If you see, I am advertising this 1.1.1. Okay. Show run section EIGRP. Oh, here also I am advertising 1.1.1. I need to advertise 2.2.2 on R2. Yes or no?
Yes.
Yes, yes.
Yeah. So config terminal router EIGRP 90 network 2.2.2.2. Here I need to remove this. That's it. Okay. Now you will see 2.2.2 you learn, right? How you
Yes.
learn? Through D here. D means what? D means EIGRP. Okay. Anna, O means OSPF, right? Why EIGRP should be E, right? Why he has taken D? You may have this question, but they design like that. Maybe it is occupied with E1, E2 routes, OSPF E1, E2 routes. Okay, I will explain this E1, E2 routes in real time stuff in boot camp on Sunday. Okay, yeah. So D means what? They might ask you in interview. D means what? EIGRP. This is administrative distance, and this is the cost. Now, if you ping 2.2.2, it will be ping. That's it. This is all about EIGRP, and make sure please remember this best path calculation process. Okay. Also, I'm going to give you this tutorial part, and please go through it, both of you. Okay. I did not made any PPT because I don't want to teach proprietary things. I want to teach only the, you know, what is that? Which we use real time. 99% we use OSPF only. So based on that, actually it is not my list. It is not my bucket list. Based on candidates demand, I'm teaching this. Okay. Yeah. Anyhow, it's good to have a knowledge on EHRP also, the basic knowledge. Okay. Do you need this screenshot? I'll give it to you. Any questions on EHRP? If you have such any questions, please ask me, guys. Any questions?
Anna, if FD is same, then first ఏది choose చేసుకుంటుంది? Sesh.
FD will not be the same, Mama.
Okay.
Okay, if you see here, right? If FD is
Mm.
same, it is
Mm.
has multiple paths, right?
Okay.
Okay, so it may have the multiple paths. Okay, so it will choose accordingly because
Mm.
uh, suppose if FD will not be the same, in case if it is the same, you need to configure manually also, or else there is a path selection criteria. There's a formula actually for calculating the paths, right? This is a formula. See,
Mm-hmm.
whatever we discuss, right? You can see the same thing here. Okay, and there is a formula here. Yeah, there is this. This is a formula to calculate the cost. So 10 to the power of 8 divided by 100. So the cost is this. This is a metric. To calculate the metric, this is a formula. Okay. So you may see formula here, right? So this is a
Okay,
formula
okay.
here, metric. This is a formula to calculate the metric. Okay. So 10 to the power of 8 divided by the link cost. If you are using 100 Mbps or Ethernet or 1 Gbps, right? That is a
Yeah.
bandwidth. That is a bandwidth plus sum of the delays in divided by 10. It will calculate it automatically. Okay. This K1, K2s are like between the routers bandwidth. Okay. Yeah. So just go through this if you need more. But in OSPF to calculate the bandwidth, it is 10 to the power of 8 by 10 into the cost. 10 to the power of 8 divided by 100 into cost. That is a formula. Okay. You may see the based on the link. This is a link, right? This is a fast Ethernet link. Based on the link, you will come to know. Okay. So no need to dig into more about EIGRP. Dig more about OSPF, do all the labs which I said in OSPF, that is enough. So maximum interview, they will ask you which routing protocol you are comfortable with. You can tell OSPF and ask, you can answer it. If anyone asks you, do you know anything about EIGRP? This is fair enough. It's similar to OSPF only, but it is a open star. It is a distinct vector routing protocol. Till 2013, it is a proprietary. After that, it is open standard. Okay. Yeah. So no one previously they might ask you this bandwidth how to calculate. Now no one is asking this. So this is a theoretical thing. Okay, this is a theoretical thing. So people may ask you about the topologies and scenarios, how the route will be calculated, which route will be installed in the routing table. Okay, yeah. So that's it, guys, about EIGRP. Such a good question, but yeah, you can download this zip file and study also. Any questions? So this is a packet tracer. Directly download it and it will open, topology will open with packet tracer. Okay. So 9-shoot is also best way, but whatever the labs I prepared, right, that is my own, which I was worked in real-time environment, right? So do those labs and explore this website, and if you want to learn more, you can learn. Okay. Any questions? Hello.
No, sir.
Yeah. So shall we move to the next topic?
Yes, bro.
Okay. So let's take uh, you know VRRP. Okay, what is VRRP? I'm going to take a switch here. Okay, and I'm going to computers. There are two computers. Okay, let's continue with this topology. Okay, now here it is 1.1, right? Here it is 1.2. Oh, sorry, this is what is this? This is 1.0 network, right? I'm sorry. This is 1.0 network. Okay, guys. Now please tell me. Let's have a connection like this. Okay. So in real time, you may see like this. You may see like this. Okay. But I want to put it in middle. Okay. Okay. Now this is one path, right? Generally, in every organization, in your home also, each and every computer, what are the important fields required? Can you please tell me? Hello?
IP address.
Very good. IP
Yeah.
address. IP
Socket
address
mask, internet mask, gateway. Internet mask.
and gateway. Very good. Okay. Now this is all about one network only. It is 1.0, right? This is all about one network. This is entire your company, right? This is your company. Generally, I'm asking. Okay. This is your company. Okay. This is your company. And you need to give this IP address, subnet mask, gateway. You may configure DHCP here. That's fantastic. It's okay. You configure DHCP. Implement DHCP also. In case here you will connect to the cloud, right? Here you will connect to the internet generally, right? What you will connect here? Here you will connect to the internet. Okay, here you may be connected to the internet. 1 second. Okay, so generally you may connect to the internet. So the thing is, it will go like this. Okay, the internet will go like this, right? You know, it will go like this. But in case this router goes down, so what you will give the gateway here, IP address you can give 192.168.1.4, whatever it is. Okay, here subnet mask 255.255.255.0 you can give here, and gateway you can call 192.168.1.100. Here the IP address of this interface is 192.168.1.100. Whatever the IP address of this E6/0 interface, right, we can give as a gateway. Now my question is, in case if this router goes down, what will happen in your environment? Your entire network will go down, right? Yes or no?
Internet will get. Yes.
There is no internet access for your computers. That's why what you need one more router. What is
Redundant
this?
route. Redundant route.
Redundant router. Yes. So you can say this is, what is this? This is master. It called
Link.
redundant, and this is backup. Okay. So the thing is, okay, I will take a redundant router and I will connect a cable like this perfectly. Okay. Okay. Now my question is, so you need to give a IP address, right? You should not give a same IP address here, right? You have to give what IP address? Different IP address.
It's a different. Yeah. Yeah. One.
Okay. Now my question is, if I give 1.0, 1.100 here, this 1.100 router went down, then what you need to do? You need to manually log into this device computer and give gateway as 1.1. Then only the packets will go like this. Yes or no, guys?
Yes.
Yes or no? Right? Yes or no? Generally, just
Yes,
tell
sir.
me. Right? Then how so what you need to do in this case? It is not feasible, right? In real time, you may be implemented DSCP, you may use only one network. And how it is possible? Gateway, we cannot give two IP addresses. There is no two gateways for the computers. You have only one gateway. You should give only one gateway. So
Then we use
we
DGP.
now we use gateway redundancy protocol. What is that? Gateway redundancy protocol. So this is called high availability protocol. Okay, what we call here high availability protocols. So how many high availability protocols we have? One is HSRP, another one is VRRP. Okay, HSRP is a Cisco proprietary again. I don't want to discuss HSRP. HSRP is widely used, but I don't want to discuss. But compared to VRRP is using more because it's an open standard. Everyone is using it. HSRP is a Cisco proprietary. Okay. Once this class is done, I will share the differences between HSRP and VRRP also. But VRRP is it is having very big advantage compared than HSRP. Okay. So which one you would like to tell me? HSRP or VRRP? VRRP using 90% in market. So they will ask you. Okay. If you learn VRRP, HSRP, it's very simple. Okay. So what it is VRRP? It's a gateway level redundancy protocol. It means let's set up everything like this. Let it be E6/0 interface IP address is 1.100, E6/0 here IP address is 1.101. Now, if you take a gateway level redundancy protocol, if you configure it right, if you configure a VRRP and HSRP, right, VRRP, so you can consider these two routers on in VRRP group, virtual group. Okay, it will consider these two routers as a one router, and it is give a logical IP, logical gateway. Logical gateway. What is that? You can choose any one of the IP address in this pool. I'm choosing 1.250. I am choosing 1.250. So what it is, you have to configure VRRP gateway as 1.250 on both the routers. Okay, logical gateway on both the routers. So here for my computers, I can give gateway as 1.250, so that for both the routers, gateway IP address is 1.250. In case if this router goes down, it will go via this path. Are you understanding what I'm saying? Generally, this is a physical IP address, but on both the routers, I can create a VRRP logical gateway. I can configure a same IP address, because this IP address I am not assigning on interfaces. I am assigning to VRRP. So I'm configuring it to R1, I'm configuring it to R2. Some big organizations, they can take one more router here and they can add in the same VRRP group. They can have three gateways, three physical gateways, one logical gateway. Understood? Three physical gateways, one logical gateway, and that gateway IP address we are assigned to here. Everyone understood? Hello?
Yes, and I have a doubt.
Yeah.
Anna, can we add a multiple routers, or do we have any limit of adding routers? Like we can
So
add group of.
yeah, you can add multiple routers. Multiple routers. So generally, any organization looking for only one redundancy only. If they add
Okay.
more and more, it will be expensive, right? Maximum three, they can add it in real time. Okay?
Okay.
Because why unnecessarily you need? So you need only two or three, maximum two, because one is primary, one is secondary. So if primary router goes down, secondary router will take a traffic and you can reach the internet, right? Worst case scenario, if both goes down, so all the computers gone, they cannot access the internet. So that's why some organizations they can take three another router also. Okay, yeah, up to 255 routers you can add it in one group, I guess. Okay,
Okay. Thank
yeah,
you.
yeah. So yeah, I don't have the real number, but you can just check it. But you can in real time. I'm saying right, maximum three routers they use. Why we need unnecessarily multiple routers? Only one is primary, one is secondary is enough. But some other organization they add one more router for safe side, for the safer side. Okay, but you can give same gateway IP address to all the routers. And my question here is, Anna, okay, you are giving gateway as the same gateway to all the devices. But my question here is, which path it will choose? Which path? Whether the traffic will go via R1 or R2? Which path it will choose? Right?
R1
How can you say that R1?
Best for
because it is a
Sorry, because it is a
master.
how it is master. Yeah, based on the topology you are saying correctly. Now, how it became master? Good ma. How it became master? Can you please tell me?
Uh, Maybe it elect with IP address which has an highest IP
Yeah,
address.
it has a priority, ma. Good catch, actually. It having a priority. Okay. So priority equal to 128 by default. Okay. It has a VRRP priority. By default is 128. Okay. So you can increase the VRRP priority if you want to become. I think VRRP priority is. Let me check. It's 150 or 100 or 128. Let me check here in this PPT. We have VRRP. Okay, let's configure VRRP. Okay, so the thing is, once you configure a VRRP on the both the routers, so it will announce VRRP packets. VRRP announcements. Here we call announcements. You can say VRRP packets. These VRRP packets will exchange through multicast address 224.0.0.18. Okay, so it means R1 will send a VRRP packet to R2. R2 will send a VRRP packet to R1. Both the routers will exchange VRRP with the priority values, so that they will compare it. Whichever having the highest priority, that will become the master. Whichever having the lowest priority, that will become the backup. Okay, yeah. So can we configure here simply? Let's quickly configure VRRP. So I'm configuring. Go to the configure terminal. Very simple. So first, before going to configure, let's assign the IP addresses on the interfaces. E6/0 IP address 192.168.1.100.255.255.255.0. It's is it overlap? Where it is overlap?
EIGRP done.
Oh, one dot. Have you given any 1.1 here? Okay, do show IP interface brief. We did
Yeah,
not given any 100, right?
it's there.
1.1
Ethernet
is,
6,
it is
6 slash
1.1 is,
0. 6 slash 0.
okay, okay. Actually 1.0 network we have already taken, guys. We need to take another network. Router should support different networks, right? So let's consider this is 2.0 network. I'm sorry. So this is 1.0, 1.0 network already being used, right? So we need to take another network. Router should interact with multiple networks, right? Yeah. Are you getting my point? Hello?
Yes,
So
sir.
each interface it has one network, right? So yeah. So it is overlaps. That's correct. So what I have to do is let me change the IP address. IP address 192.168.2.100. It's a different network. Yeah. No shutdown. And now let's go to R2 interface E6 class 0. Is it E6 class 0? Yeah, it's E6 slash 0. And what is the IP address? 192.168.2.101, right? Yeah, just assign the IP address and no shutdown. So now after assigning an IP address, I'm going to take a packet capture here. See, start capturing it. Let's see the packet capture. So once I configure the VRRP, you know what it will do? It will quickly announce the VRRP packets through multicast address 224.0.0.18. See, let's see. So VRRP. So you need to, so IP VRRP. One second. What is the commands? VRRP. Do show VRRP all. Nothing I have configured. Now I need to configure. You need to enter into the interface, right? You should not configure on global level. Where you are configuring as a virtual gateway. Which interface you are configuring virtual gateway? Which interface you are configuring virtual gateway?
6
Logical
slash 0.
gateway.
6
Very
slash
good.
0.
So you need to enter E6 slash 0 and VRRP. You need to give a group. I told you, right? You have to give a group. Here, how many groups you will see? Up to 255. Yes or no? Up to 255. In HSRP, it will only 10. That is a major difference. That's it. So now I'm taking a VRRP group 10, whatever it is. And what you need to give IP, the gateway. See, if you give enable virtual route, if you want to enable VRRP, right, you need to give IP. It means gateway. What is the gateway? 192.168.2.250. Sorry, it's 2.250. We have changed, right? 2.250. Okay. VRP gateway, and that's it. I given a gateway IP. Now, if you after giving the IP, right? See what it is seeing. It start announcing VRRP packets. Are you seeing it or not? VRRP packets. See, so the router one means 2.100 is announcing VRRP packets through multicast address 224.0.0.18. Yes or no? Hello? Are you seeing it here?
Yes, sir.
Yes.
Right? So what is the VRRP protocol number? 112. Please remember. And also always remember the multicast addresses, MAC addresses. What will be the multicast address MAC addresses? It will be,
0.18.
yeah, it will be calculated. So you need to remember only for these three hexadecimals, okay? 010058 5E. Okay, just remember these three things. Okay, 01005E, and the multicast MAC address for 118 is last ends with dual 12. If it is 5, right, it is 5, it's ends with 5 here. Okay, so fine. So now VRRP packet is generated and sending to multicast address 224.0.18. This is a VRRP packet. And now see what is the priority here? It is 100 here. Okay, it is 100. So let's configure. If you want to become this is a master, right? Let's configure priority. So VRRP, what is the group we call 10, and take a priority. So if you see here, right, you can take a priority. What is the priority I can give? I can configure 1 to 254. So I'm configuring here 150. See, now I have configured 150, right? So now it will announce for every second. For every second, it will announce a VRRP packet. See, it is announcing a VRRP packet. Let's take a new VRRP packet. See, now it is 150. I configured 150 priority. Now you will see 150. Earlier you were able to see 100, right? So earlier you were able to see 100. See, earlier you were able to see 100. Now I configured 150. You will see 150 here. Yes or no? Hello?
Yes,
Yes, sir.
Yeah. Now see, these VRRP packets are announcing from 2.100 only. I did not configure VRRP on this R2 router. Let's configure VRRP on R2 router. Okay. Yeah. In each interface, yeah, E6/0. I'm on E6/0 only. So now VRRP, make sure the group number should be same. What is the group number we called?
10.
Very good. 10. And IP address. What is the IP address? 192.168.2.250.
2.250.
That's it. Here you no need to configure VRRP. So see, quickly it receives a VRRP packet from R1 to R2. Quickly it move to backup to init and init to backup. So now it is in backup. Okay. If you see, right, now it is in backup.
What about
Okay.
priority?
Priority no need to configure, right? It is default 100. So now by default, what is the priority here? It is 100. Here it is 150. We configured 150 here, and here you don't need to configure because priority is 100 here, right? See, do packet
Yes.
capture if you want. You can take a packet capture here. See, 2.100 is sending a VRRP packet. Why 2.100 is sending? Because 2.100 is a master. So master will send a VRRP packets to the backup. See, this is a master, right? Let's check. Show VRRP all or brief. So now you can see state is master. Okay, or else show VRRP brief. You can see. So state is master and the priority is 150 here. Okay, group is 10. So this is a master. And if you see R2, right, this is a backup. Do show VRRP brief. See, now you can see it is a backup. Make sure R1 should be master, R2 should be backup. Okay, then only the packet will reach. Can we now check from PC? Can we ping the gateway? Let's see. Let's ping the gateway. So if you ping the gateway, it should go via R1 now because R1 is the master. Okay. See now, IP. Let's assign IP. IP 192.168.2.1 is IP. Gateway is 192.168.2.250 is the gateway. Once IP detail, yeah, it is addressed. Now ping 192.168.2.250. So the gateway is pinging successfully. Now let's see which router it is taking. Trace 192.168.2.250. Now it is reaching via 2.100. It means it is going via R1. 2.100 is become 2.100 is belongs to R1, right? Guys, are you getting my point?
Yes, yes.
The traffic is going via 2.100. Now can we please shut down this R1 interface and see? Let's shut down. So within 1 minute, R2 will become a backup because for every second it is sending VRRP packets to R2. In case R2 did not receive any VRRP packets within 2 seconds, R2 announce himself as a master. Okay. In case R2 is not receiving any VRRP packets for 2 seconds, right? It will announce himself as a master. Now this is a R2 packet capture. So every second 2.100 is sending a VRRP packet, right? Let's shut down R1 interface and see. This is R1, right? So config T, interface G, interface E6/0. I'm shutting down. See, I'm shutting down. Now what happened? See, it is quickly changed. Now 2.101 is sending a VRRP packets quickly because 2.101 is the master now. Only master will announce the VRRP packets saying that I am the master. Now can we check the roles here? See, now it became, see, now it became It's nothing here because it's down, right? Now it is became master. See, it became master. Let's check. Let's check it. Now it became master. 2.1 became master. And if you want to ping, if you want to ping the gateway, let's ping the gateway. Where is I am? See, it is pinging the gateway, and it is going via 101. Is it clear, guys? Hello, is it clear? Yes or no? So
Yes, sir.
now
Yes.
let's initiate a ping 192.168.250 continuously. Okay. Okay, let's initiate a ping -t. Okay. Now I want to get back the interface. I want to bring up the interface. One R1 interface comes, right? Again R1 will become the master because it has the preemption. Here in VRRP we have a preemption. Preemption in the sense, if it is whatever the state it is having in the previous state, the same state it will go. Okay. Now see, the here the gateway is continuously pinging, and let me do no shut now. Have you seen any packet drops? You may see one packet drop, maybe one packet drop. See, you have seen only one packet drop and continuously it is pinging. It means the packet is going via again 100 now. So it means the computers does not have any issues in case the router goes down. Through SBA branch office project, right? That is towards ISP we did a redundancy. This is towards LAN. This is towards your LAN network. Okay. This is towards your LAN network. In case if anything goes down towards your LAN network, we use VRRP here. So everywhere they use VRRP, guys. Remember this thing. Okay, in real time, you may see both the routers are announcing themselves as a master. Then what is the problem here? If R1 is announcing himself as a master, R2 is also announcing himself as a master. It means both are saying that I am the gateway, I am the right path. So it is not good. One router should be master, one router should be backup. Then only the traffic will flow. If both are saying master, your computers will not reach any internet. So now what is the reason? Can anyone guess? If both the routers announcing themselves as a master, what could be the reason? How the master backup elections will happen?
Based on priority.
Very good. Based on priority. Now, where the priority you will see? In which packet you will see the priority? In which packet you will see the priority? So I am opening here. So in which packet you will see the priority? Just see the screen and tell me. Are you guys seeing my screen? Which packet?
Yes.
Sorry, what is
Dual
that?
router redundancy protocol, sir.
Yeah, VRRP packet, right? In VRRP packet, you will
Yes,
see the
yes.
priority. So VRRP packet, you will see the priority. The packet will go here, and both the routers are exchanging VRRP packets. Then only they will elect as a master, right? They will compare it and they will elect as a master backup. Now both the routers are not reaching their packets. It means R1 sending a VRRP packet to R2, R2 is sending a VRRP packet to R1. But somewhere in between, switch, it is not forwarding the packets. That's the reason they're not reaching the packets and they're not comparing their priorities and they're not electing a master backup things. So what you need to troubleshoot? You need to troubleshoot on switch. Understood? You need to troubleshoot on switch. Okay?
Yes.
Yeah. Okay, now that's the thing, guys. And one more important question in interviews, please listen. So when primarily this is a master, right? So if it is a master, right? Master is announcing VRRP packet, right? Switch is receiving, so that switch is updating his MAC address table. The primary path is Goya E0. Now this is not announcing, right? R2 is not announcing. That's why to reach internet, to reach gateway 254, E2 interface will not be shown. Once this interface is down, right? Again, R2 will announce a VRRP packet uh, through gracious ARP. Gracious ARP. See, if anything happened, right? Immediately the gracious ARP will be comes into the picture. If you see at the top also, the gracious ARP will update a MAC address table in a switch. See here, the gracious ARP 2.50. So this will update it. in a MAC address table. It means in case if the primary path goes down, how the switch will come to know should I send a traffic to the R2? How R2 will announce a VRRP packet, the switch will receive it and it will update a this source MAC address, right? It will update a source MAC address on E2 interface so that the computers, whatever the traffic which is coming from the computers, it will send through E2 interface. Now it will remove from E0. It will remove the MAC address on E0. Are you getting what I'm saying? Are you really getting what I'm saying?
Yes, sir.
So initially, how many interfaces we have on switch? E0, E1, E2,
E2,
E,
E3.
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 So what are the interfaces which are going to the gateway? E0 and E1. So currently the master is R1, right? So it will learn the MAC address of VRRP, right? VRRP means it is 5E. Just consider this is 5E.18. So it will learn the MAC address on E0. So it will the traffic, all the traffic will go via R1. So it means sorry, R1 MAC address. You can say R1 MAC address is R1. Okay. So generally this is a master, right? So what it will happen? It will generate a gracious OR to check whether 2.250 anyone having the 2.250 or not. It will check a gracious OR, right? So it will check a gracious OR and it will come to the switch. Switch will learn it. Okay, the MAC address of. So what MAC address it will learn? It will not learn a virtual. It will not learn a physical MAC address, guys. It will learn a virtual MAC address. What is the virtual MAC address here? 5e, right? 5e.89 12. That is this is a VRRP MAC address, right? If you see here, right? This is a MAC address. Where is it? 5e.12. This is a MAC address. So it will learn the virtual MAC address here. Okay. Now it is not learning any MAC address even. It is empty because who is announcing the VRRP packet? R1 is announcing. That's why it is learning on E0. Now what will happen? This link went down. Within 2 seconds, the MAC address will be deleted here and R2 is updating his MAC address, same MAC address, virtual MAC address, and it will learn on 05 5E12 here. 5E12 here.
But that is also same way.
That is also same. That's why it is removing, right? This 5E12 is removing on E0 and is updating on E1. It is telling that hey, it is updating the MAC address table, telling that hey, the R1 link is down. Remove your MAC address. Now the traffic is should pass through R2. Update your MAC address table with multicast MAC address. Okay, yeah, definitely you should have a gateway MAC address in your MAC address table, right? Then only it will pass the traffic. Switch will only forward the data based on the MAC addresses, right? Yes or no? So that's why you should update the MAC address here. Okay, it is very deep, guys. So maybe in product based companies they will ask you this question. Okay, so how the switch will update their MAC address table based on the gracious OR. When the primary link goes down, immediately the gracious ARP it will send, so that switch will update it. The source MAC address. What is the source MAC address? The multicast MAC address. Okay. This is all about VRRP. Any questions, guys, about VRRP? Hello. So the last one I'm telling is, so switch we have the MAC address table, right? Initially, the primary path is R1. So that's why R1 E6/0, it will not learn any physical MAC addresses. It is learning only the logical MAC address. Since we are using destination IP address 2.50 on both the routers, right? It have the virtual MAC address. It's the same MAC address. Okay. But same MAC address you should not learn on two interfaces. If it learn on two interfaces, it is called MAC loop. With the same MAC address. So the data will receive here with the destination MAC address of 5E.12. How switch we can forward the traffic to two interfaces? It won't, right? It will not do that. So once the E6/0 link down, right? E0 will remove the MAC address because the link is down. So now this will generate a gracious OR and it will E2, right? This is E2, sorry, this is E2, not E1. So E2 will update with virtual MAC address with gracious R. Okay, yeah. Once the link is come back, right? Once the link is come back, again R1 is update the MAC address table with a gracious R. Hey, again link is come back, so that E2 will remove it and it will come here. E0, it will update with E0. Okay. Always E0, E2 are connected to the routers, gateway routers. Either E0 or E2 will be the one, only one is the path which should forward the traffic. Okay. Yeah, that is all about VRRP. Any questions about VRRP? So VRRP is very important, right? To provide redundancy at gateway level. Okay. Yeah. Any questions? Any questions?
No, sir.
Yeah. So for March 10th batch, guys, the syllabus is completed for you. For extra topics like SSH and EIGRP, sorry, not EIGRP, SSH, and I want to tell you SSH configuration as well as trace route. I will explain you this in boot camp in Sunday class. Okay. So everyone join the Sunday class. I will explain you about trace route, SSH with TCP. If you want to learn more about TCP, TCP is ruling the world. If you want to learn more about TCP, join the Sunday bootcamp classes. Real time in scenarios I will explain. That bootcamp class is for everyone. Okay. So TCP I already explained with BGP. So March 20th batch I did not teach you BGP. When I teach BGP I will explain TCP. So TCP used by many protocols, right? So if you want to learn TCP along with SSH, right? SSH port number. What is the TCP port number? SSH TCP port number,
22.
right? Yeah, you want to learn in real time, right? If you initiate SSH, what exactly is happening at the back end? TCP, how it behaves. So we can learn on Sunday. Is it clear? Okay.
Yes, sir.
Yeah. Trace route also. Trace route. If you initiate a trace route, here I initiate a trace, right? What exactly the transactions will happen? So trace route, right? If you initiate a trace, how exactly it is displaying the next hop? I will teach you on the bootcamp class. Okay. Very important sessions, packet level. Okay. So for March 10th batch, it is clear for you. The syllabus is completed, and March 20th batch for you, the routing technologies are completed. So from tomorrow, we can continue the switching technologies. We can finish it by in 3 to 4 days, switching technologies as well. Okay. Yeah, that's all for today. If you have any questions on VRRP and anything, right, let me know. So yeah, that's all guys.
బ్రో ఇది మనకి వ్యాన్ కనెక్షన్ డౌన్ అయితే ల్యాన్ కూడా డౌన్ అవుతుంది.
Yeah, that's what, right? But WAN connection అనేది R1 WAN డౌన్ అయితే నీకు రిడెండెన్సీ ఉంది కదా ఇక్కడ బ్యాకప్. ఇట్లా WAN LAN డౌన్ అవ్వదు. అందుకే రిడెండెన్సీ మనకు.
నో
ఓకే.
యాక్చువల్లీ రిడెండెన్సీ కోసమే. సో యాక్చువల్లీ అంటే R2 తెలుస్తుంది కదా, సో అంటే ఇది డౌన్ అయినట్టు.
యా యా
సో
యా R2కు తెలుస్తుంది. ఎందుకంటే ఇది ఇట్ విల్ నాట్ అనౌన్సింగ్ VRRP ప్యాకెట్స్, రైట్? ఇట్ విల్ వెయిట్ ఫర్ 2 సెకండ్స్. ఓకే, R1 నుంచి ఎటువంటి అప్డేట్ లేదు కాబట్టి ఇట్ విల్ బికమ్ ఏ మాస్టర్ అండ్ ఇట్ విల్ టేక్ ఓవర్ ద ట్రాఫిక్. యా. హలో, కెన్ యూ హియర్ మీ?
ఎస్ ఎస్.
యా. సో వాట్ ఈస్ యువర్ క్వశ్చన్?
అంటే లైక్ సమ్ టైమ్స్ ఐ మీన్ సో R1 కి ఇంటర్నెట్ కనెక్షన్ ఆఫ్ అయింది. సో ఈ ఏదైతే స్విచ్ కనెక్ట్ అయిందో ఆ లింక్ అప్ చూపిస్తుంది. సో ఆ ఎగ్జాక్ట్లీ.
యా, దట్ ఈస్ ఓకే. సి
సో అప్పుడు R2 కి ఎలా రికగ్నైజ్ చేస్తుంది, ఇది మనకి ఈ లింక్ అప్ చూపిస్తుంది.
సో యు మీన్ R1 to R2 the link is down, right?
Exactly.
So R1 to R2, if the link is down, it means the connection towards the internet, right? If the link is down, okay, it's a very good question. Go on mute, I'll explain. Okay, if the BGP, you can say if you configure any BGP here, right? If the BGP is down here, you have a BGP path map. Are you a March 10th batch or 20th batch, brother?
20th batch.
Okay, so you haven't done BGP. So you will come to know you need to apply BGP path manipulation here. Okay, once your BGP neighbor goes down, the traffic will switch over here automatically. That is WAN level. You no need to do it. You don't need to do at LAN level. WAN level, it will automatically take over the path. The routes already installed in your routing table. It's stating that this is the best path. Okay.
సో అప్పుడు మనం R2 లో కూడా కాన్ఫిగరేషన్ యాడ్ చేయాలి కదా బ్రో?
ఏం కాన్ఫిగరేషన్ యాడ్ చేయాలి?
సో అంటే ఈ మనకి నైబర్స్ R1 లో డౌన్ అయినప్పుడు సో
That's what, man. That is what about BGP. You haven't completed BGP. WAN port, we haven't touched it, right? BGP. I will teach you I will teach you later BGP. Okay. So here in real time they will configure BGP or else remove BGP. Configure OSPF between. Take one more router here. Just configure this router IP address as 8.8.8. Configure OSPF and remove the link here. Okay. Simple. Okay, I'm just removing here. So let me take a real time 1 second. Let me take a server Ubuntu server here. Yeah, it is turning on. 1 second. I'm going to take a cloud. Okay, these are real cloud now. Once it is turned on, let's see. Oh, that's awesome. Quickly it is turned on. Okay, so let's take a real cloud here. Okay, so now it's real internet because I created like that. So let's see. This interface /1 is connected to not here. I need to configure. Why it is saying I think VMnet. I need to check it. 1 second. Yeah. Why it is not showing VMnet here? Or else you can use NAT. Okay. NAT interface VMnet is missing. You need to install VMware. Oh, NAT is missing. Okay. 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 You do one thing, brother. I will give you. I will. Simple. Take a router here. Okay. Take a router and configure connect a link here 2/0, connect a one more link 2/0. Okay. Okay, so consider this is 8.8.8 Google. So if you have time, guys, you can stay here. Let's implement this lab as well. Okay. Okay, based on your requirement. I have time. I will implement. Okay, so quickly I will configure here. Okay, so config terminal interface G2/0. I am taking IP address 13 here, 192.168.13. It is 3 right here. Okay, no shutdown. Interface loopback 0, 8.8.8.8. What is this? This is 255, right? Okay. Now let's configure EIGRP only. We have already configured EIGRP, right? EIGRP. What is it? 90. So let's advertise network 192.168.13.0.255. And next another network 192.168.2.0. LAN network also you need to advertise, right? That's it. Oh, no. I need to remove this. Are you guys are understanding what I'm doing now?
Yes.
I'm just creating a topology which I'm not sure who, I didn't remember the name. So whatever you guys are asking, right? Same thing I'm doing. So next one is interface G1/0 here. Okay. IP address 192.168.23.3. Arey Baba. Okay. 255.0. No shutdown. And also I need to advertise this EIGRP 90. network 192.168.23.0. Okay, 255. That's it. I have advertised everything here. I think did I advertise 1.0 here?
No,
Actually, 2.0 is not required here. 2.0 is not required because I need to advertise on either R1 or R2. Okay, router EIGRP 90. Let's remove 2.0 because here it is not required. Okay, cool. So go on R1 now. Just configure EIGRP. That's it. Exit router EIGRP. How much? 90. What is the network we need to advertise here? 13 network, right? Yeah. Network 192.168.13.0 255. That's it. And one more network on R2. Router EIGRP 90. Network 192.168.23.0. That's it. And IP address I need to configure, right? I need to configure interface G2/0 192.168.23.2. No shutdown here and here. What is IP? G2/0 192.168.13, right? 13.1, right? This is 1. Now, if you see, right, all done. So IP, EIGRP neighbors, if you see, right, you will see with google.a.8 also. If you see show IP route, you have the route 8.8.8 now. Or do you have the route 8.8.8? I think I did not advertise 8.8.8 here. Did I advertise it or not? I think I did not advertise here.
no.
Yeah, let's advertise EIGRP 90 network 8.8.8.8. That's it. Now you may see 8.8.8. Yeah, you will see 8.8.8, right? Now let's bring from PC1. Okay. PC1 where I'm okay. Ping 8.8.8.8. It will not ping because I think either of one I need to advertise 1.0 here. Okay. EIGRP 90. I need to advertise right router EIGRP 90 LAN network I need to advertise. Network 192.168.2.0. Okay. Now let's ping from here. It is pinging. So can we see the path? Which path it is choosing? Trace 8.8.8.8. Who is the master? 2.10, right? It is taking 2.13.3. So 13.3 is which IP? This IP, right? This is the 13.3. Now
Yes,
can we shut down this link so that you will get a clarity, right?
yes,
Right,
yes.
brother? That is what you are expecting, right? Yeah, let's do that. Configure terminal interface G2/0 shut. I shut it down. Okay. As per the VRRP, how it behaves, let's check from PC perspective. So now let me whether it is pinging or not. It is pinging. Perfect. Let's see how it is choosing. It is choosing via 2.10, 2.100 only. Via it is going via 2.100 and it is going via 1.2 path. It is choosing this path. Are you understanding this path? Okay. It means the data. You can see, right, the data is going via, oh shit, okay, one second. Data is going from here to here, here to here. It is going via like this. Are you getting my point?
Yes, got
Okay. Generally, they will establish
it. Yes, perfect.
they will establish a routing protocol session between these two routers also. Okay. Let's do one thing. Let's remove this link as well. Can we shut down G1/0? This G1/0, right?
Yes,
Let's check G1/0. Okay. Let's shut down R1 interface G1/0 and shut down. Okay. Now let's do. Will it ping? It is not pinging. It means host unreachable. ICMP error code 3.1. So gateway is not reachable. So generally in these situations, right, you must have a, so whatever VRRP works, right, VRRP works at LAN level, not WAN level. That's why I told you, the VRRP is a gateway level redundancy protocol. If upper link is down, you need to make sure routing should be established. Understand? Do you understand? So whatever you're talking about WAN level, right? WAN level, WAN protocol should be configured. This is VRRP is a LAN level. This is a LAN setup. Okay. This is a LAN setup. The ultimate thing is you need to check whether the gateway is pinging or not. That's it. Not A.A.8. Let's see gateway is pinging or not. Okay. 192.168.2.250. It is pinging. That's it. So VRRP is responsible for gateway redundancy protocol, whether the gateway is pinging or not, in case any one of the downlink is down or not. This R1 towards downstream. Okay. Upstream it is a WAN level. Okay. For internet, you have to make sure routing should be perfect. Are you getting my point? Hello?
Yes, sir.
Whoever is asking this question, it is applicable to everyone. So VRRP is only to check the gateway level only. The gateway level, it will do protection, not for internet level. Internet level, there is a lot of routing is involved, so that routing should be perfect. So in real time, they will establish a connection here. As I said here, right? Luckily, I have a connection. In real time also, they will configure a one BGP session here. So that in case the upper side, WAN side, if WAN side is this link go down, you have another link, right? It will go via this. This is the actual path. Okay. Yeah. And thank you so much for asking this question. It will help so many candidates. Okay. So these are real-time stuff, guys, which really configured. I configured EIGRP, but they didn't configure EIGRP. In real time, they configured BGP. Okay. BGP. Okay. Okay. Do you need the screenshot?
Yes.
Okay. I will provide to you. Okay. So yeah, in case if you need such kind of cross questions, right, let me know. We can implement on Sunday. Right away, we can check it in front of you. Okay. Yeah. Thank you so much for the session, guys. Please go through it and do lab. Thank you.